Okay, good morning everyone. This is 7.7, solve right triangles, and the objective is you will use inverse tangent, sine, and cosine ratios. All right, in the past, what we have learned is if you want to use, or if you want to solve for a side, you would use the regular sine, cosine, or tangent function. Oh, and this goes in the right-hand side of your notes. The new stuff is if you want to find an angle, you would use, it's called inverse sine, inverse cosine, and inverse tangent. Okay, and I'll explain more once we get into this first example. Now, it's going to be a little bit weird because I'm only going to, there's a couple examples here, but I'm only going to throw in two of them because there's basically two major types. All right, so for the first one, the directions I am going to switch. I'm going to switch, and I'm going to put solve the triangle. All right, so the parts of the triangle we need to solve are the sides and the angles. And then we list off all the sides. Excuse me. All right, and then we got the three angles. Okay, so currently on this diagram, we do know some of the information. We know side CB is 15. We know side AB is 20. We know angle B is 90. The next thing, I have to decide if I'm going to continue solving angles or sides, and here's what I do. I look at how many sides I currently have solved for, and then how many angles. I currently have two numbers for the sides and only one number for the angles, so I'm going to continue with the sides. To solve using the sides, I would use c squared equals a squared plus b squared. This unknown side is AC. I'll put an x right there. And I'm going to use the formula x squared equals 15 squared plus 20 squared. X is my hypotenuse, that's why it went all by itself. Okay, so I'm going to have to punch in the calculator here and get the answer. I got 25. So x equals 25. The sides are done. Here's what's brand new with this this lesson. We now got to go for the angle, and to solve for the angle, you have to use inverse. So first we're going to start at an angle, an acute angle like angle A. And now I identify what I know about the triangle. I know that 15 is the opposite side. Notice how I'm not using x. I could throw in 25, but right now I'm just going to use 15 and 20. 20 is the adjacent. So I'm going to be using the opposite and the adjacent. That's the tangent function. So tangent of angle A equals a fraction, and that fraction is 15 over 20. If you want to solve for A, you have to move tangent to the opposite side, and that's where the inverse tangent comes in. So A equals tangent to the -1 power of 15 over 20. I'll also have to throw that in my calculator here. Give me a second. Getting 36.9. Okay, so I got angle A done. Now I got to go with angle C. Inside a triangle is 180 degrees. If you take 180, take away 90, you'd be left with 90. So I'm going to be taking 90 minus 36.9. 53.1. And those are all degrees, guys. So the triangle is solved, all of the sides and all of the angles are done. So your takeaways from this. What you want to do is, if you're solving for a side, use regular sine, cosine, tangent. If you're solving for an angle, that's the inverse stuff. Check out how many sides you got. Check out how many angles. If you got 2 of the 3, it's pretty easy to solve for the third one. Okay, so I'm only going to do one more here, guys, and I was going to page ahead here and get this one in. Okay, so this would be the second one for your notes, and let me list all of the sides and the angles. Okay, now I'm going to fill in the numbers that I currently know. I know that MK is 8. I know that angle M is 40. And I know that angle L is 90. Those are both degrees. Okay, so now I'm looking at the sides and the angles and seeing how many are filled in. I notice on the angles, 2 of the 3 are filled in. So what I'm going to do is I'm going to solve for that third angle inside a triangle. The total, the sum of the angles interior, is 180. So if you take 90 minus 40, that'd leave you with 50. All right, I'm getting closer done. Now we move over to the sides. What you do is if you start from an angle, like M, we know that's 40 degrees, we're going to use a trig function, but first we have to point out what we know. We know the hypotenuse is 8, so we'll label that as the hypotenuse. Let's solve for LK, and LK is currently the opposite. And if you want to throw the letter X in there, I suppose you could, but I mean, it's the opposite. The trig function that deals with opposite and hypotenuse is sine. So I'd have sine of 40 degrees equals the opposite over the hypotenuse. And I like to solve using proportions, so I'd have 1x equals 8 times the sine of 40. Right, give me a second, I'll punch that in. All right, I'm coming up with 5.1. Okay, and I am going to erase this bottom part here and start over. There are 2 ways to solve for that third side. Some students love using c squared equals a squared plus b squared, and other students like to set up another trig function. Because this is fairly new, I'll throw another trig function out there. So I'll put a letter y right here, and that's called the adjacent. Remember, we're going from angle M.
We need all New Directions students to come to the attendance office at this time.
So we have adjacent and hypotenuse are the ones we want to go with. We really don't want to use this one right here because it was a rounded number. 5.1 was rounded. So let's go with the adjacent and hypotenuse. That's the cosine function. Cosine of 40 degrees equals the adjacent over the hypotenuse. Using proportions, cross them up. 8 times the cosine of 40. And 6.1. Okay, so those are the 2 main types for lesson 7.7. I rewatch the video as many times as you need. Come up with your questions in the morning, and I'll be glad to help you out. But good luck with everything, and I hope you have a great day or weekend, whatever is coming up.